Oops. That's okay. What is it? Solids. Solids, right? So, right. See now. So let us mechanical properties of solids. See, question number 8. Yeah, question number 8. So the question is this. Hello. Hello, madam. I'm right now. I'm in a class. Can I call you back later? Yeah. Hello. చెప్పమా ఒకసారి మా బ్రదర్ కాల్ చేయమ్మా నేను క్లాస్లో ఉన్నాను నా నెంబర్ మెసేజ్ వాట్సాప్ చేసి మీ దగ్గరే లేకపోతే గత కాల్ చేయండి right. Yep. Sorry for the disturbance. Yep. Okay. Yes. So the question is question number 8. Question number 83. Right. So it is given that the question is it is given that 4 identical hollow cylindrical columns of steel support a big structure of mass 50,000 kg. The inner and outer radii of each column are 30 cm and 40 cm respectively. Assuming the load distribution to be uniform, calculate the compressional strain of each column. The Young's modulus of steel is 2 into 10 power 11 Pascal. Right? What you have to consider here is, so 4 identical hollow cylindrical columns of steel support a big structure. Let us say there are 4 cylindrical structures are there. This is one cylindrical structure having inner radius of let us say having inner radius of r1 and outer radius of r2. This is one structure. Like this, how many are there? 4 are there. Like this, there is one more. This 2, with again inner and outer radii, and one more with inner and outer radii. Right? 3, 4, right? So you can take actually to here side by side. This one, then here, here one, another one. Like this, you can also consider. Actually, you can consider that way. Not like this one side by side, or you can consider this 4 side by side. So this is R1, and there is another one having radius of R2. Okay, these cylindrical structures support a very big, massive object of mass V, right? Now what happens is because of this equally the force is acting, mass is distributed equally. You can say this because of this force called a gravitational force acts downwards. So this force acts on this and this and this and this. Okay, now because of this it will this rods will undergo compression. We have discussed during the class on a simple examples that there is a wire having length L, and if it is having some mass, that mg force will act downward as nothing but mg on this area. Then stress of F by A stress will develop, and because of this stress, length will increase by delta L. So Young's modulus is equal to FL by A into delta L. So here this is delta L. Increasing length will take place because of this normal force acting downward, so length will increase. But here these edges are fixed. These are fixed ones like this. So force is acting like downward direction, so the length will decrease. Now we all are having what is the length L. Now the length will decreases by small amount. Let us say very small amount, not that much observable, very small amount. Let us say that is delta L, right? Now the question is, let us consider note down the data point by point. Four identical cylindrical cells of a hollow cylindrical columns of steel support a big structure of mass, where mass m is equal to 50,000 kg, means 50 into 10 to the power 3, or you can say 5 into 10 to the power 4 kg as acting. The inner and outer radii of each column, let us take it as R1 and R2 of each column are 30 centimeters, means 10 to 13 to the power minus 2 meters, equal to 3 into 10 to the power minus 1 meter. This is 40 centimeters. So 40 into 10 power minus 2 meters equal to 4 into 10 to the power minus 1 meters. Inner and outer radii R1, R2. Assuming the flow distribution to be uniform, calculate the compressional strain of each column. Compressional strain delta L by L of each column is what? The Young's modulus of the steel is Y is equal to 2 into 10 to the power 11 Pascal. Got it? We know we know that Young's modulus in general is equal to stress by strain, linear stress by linear strain, or longitudinal stress by longitudinal strain. That is force by area by linear strain is delta L by L. Just you are directly asked to find what is delta L by L for each column. So from this we can say delta L by L is equal to, or if you take this here, Y comes here, then you will get F by A by Y, or you can say F by A into Y. Here F is nothing but mg mg by A into Y. But A, you have to take this as one mg. What is mg? What is Y is given in what is area? Area you have to take carefully. This is I can say the strain produced in each column, each cylindrical column. So this one, right? So from here you can say where area is a hollow cylinder. Hollow cylinder means you can understand this. This is hollow. Only material will be only here. Only material will be distributed only here. So that means this area only will act.
Hmm. So that way force is acting now, sir. That will be divided among the four now, sir.
So here,
F by 4.
yes, it is distributed equally. Yes, that way you have to consider here. So now, what is the thing is, what you have to consider is, this similar kind of things we come across in springs, if you remember. If same elongation is taking place, so series combination and parallel combination of springs. The series combination and parallel combination of the springs, like there we have discussed it, right? Like that here, just one of these combinations we have to apply here. What is that combination? If you remember springs, if two springs are here like this, if a load is connected like this, right? if mg is acting down, right? So if force is so that if it is elongating, so this entire system is elongating by some x distance. So it cannot elongate x1, this cannot elongate x2. Same x means different forces will act on this. The force will distribute. So F1 plus F2 will be this. Same way, the total force will be distributed equally. Distributed equally. So accordingly, you can consider this one. So what is given here is the of course. So that the same thing you can make use of here, but okay, fine. Then we can consider what is this area should be pi is area of circle is pi r square, but area of the only distributed part is pi into outer radius square minus inner radius square, or pi r2 square minus pi r1 square is equal to pi into r2 square minus r1 square is the area. So you have to find out the area. R1 r2 are given, find out this Young's modulus is given. Okay, then you have to consider as total mg is acting on this or it is distributing. So as it is given that the total mass is distributed uniformly, and it is also given that the four identical cylinders columns support this big column is like this only. So then you can say that the force, whatever you can say, the force also distributes accordingly. So consider that. So let us take it as by 4 and calculate and tell me how much you will get. And calculate this, substituting this and calculate, tell me how much you will get.
1.1
How much?
1.1
If you take by 4,
by 4.
G, how much you are taking?
So 10 sir.
10, we take it as 9.8.
2.75 into 10 to the power minus 6.
2 point
75 into 10 to the power minus 6.
approximately.
2.78.
Yes, correct. Right. So that's why you have to some the
Area.
options sometimes will be based on g value as 9.8 or 10. Accordingly, you have to take it. So only area have to be careful. And here, as force is, I mean mass is distributing uniformly, this F will be mg by 4. You have to consider here mg by 4. You have to consider this F is nothing but mg by 4. F is force on each column, cylindrical column. Mg by 4 you have to consider. Then automatically you will get. So you'll observe that delta L by L is equal to approximately how much? 2.78 into 10 to the power minus 6 is delta L by L. No unit. No unit. That's it. Okay. The other things we will see. Level 1 it is given. In level 1 only it is given. It's direct substitution only. Only the terminology we have to understand only when this concept is discussed. So we have to have a brief discussion about that. What is this Searle's experiment? Searle's method or Searle's experiment. It is used to calculate the Young's modulus experimental. It is experimental method to calculate that. We'll see that anyway, but briefly, what you can understand here is question number 4. And the question is, the Searle's method to determine the Young's modulus of a wire, a steel wire of length, it is used to calculate Young's modulus. Okay? A steel wire of length L is equal to 156 centimeters is equal to 156 into 10 to the power minus 2 meters, and diameter is equal to 0.054 centimeters. It is equal to 0.054 into 10 to the power minus 2 meters. We may use the radius, diameter by 2, we will take it as radius. It is used as an experimental one. So now the average increase in length for 1.5 kg weight. 1.5 kg weight is the force. Okay. So kg is mass. Kg weight is unit of force. Is a force. Force, actually, unit of force is Newton. This unit. Therefore, for force, there are two types of units here: the conventional units and gravitational units. Conventional unit is Newton in SI system, dyne in CGS system. So this conventional units, right? But the another kind of units called gravitational units are there. Gravitational units, SI system gravitational unit is kg weight is SI unit of force only, but in gravitational unit of force in SI system, and CGS unit gravitational unit of force in CGS system is gram weight. And but this is not this is actually this is gravitational unit, not conventional unit. Usually conventional unit we will make use as an SI unit actually. So this will be convert this we have to convert into newtons while doing the numericals to find all final result in SI system. So this is equal to 9.8 newton. 1 kg weight equal to 9.8 newton or 10 newton. This is equal to 980 dyne or 1000 dyne approximately, I can take. So then accordingly you can take this values, the final values. So now it is given that, if you come back to this question, um, the average increase in length for 1.5 kg weight is found to be 0.05 centimeters. Increase in length is found to be 0.05 0.050 or 0.05 centimeters, 0.05 into 10 to the power minus 2 meters. Then the Young's modulus of the wire is what? Young's modulus of the wire is what? Direct substitution only. We know Young's modulus is what? F L by A into delta L. Here F is given, but in terms of kg weight, it is equal to 1.5 into 9.8 or 10 also you can take. What? Newton. This will be Newton now. F is given, L is given. L is given as this much, right? Area. Uh, area is given? No. Delta L is given? Yes, average value of delta is given. Then how to find area? Where area, because diameter is given. Area of a cylindrical wire is pi r square. This can also be expressed as pi into diameter by 2 is radius whole square. You find out this area, and where area is equal to area A is equal to this. Find out area where delta L is given. Everything will be known. Substitute. Then you will get approximately what is that, 2.5 into 10 power 11, sorry, fourth one, right? 2.002 into 10 power 11, 2.002 into 10 to the power 11 Newton per meter square or Pascal. Not this area, this one. 2.002 into 10 to the power 11 Young's modulus Newton per meter square will be the answer for this. So to find out this, you have to find out this. You have to find out this, and if you substitute this value, all values here, then you will get this much. Okay. What is what is telling? The length of each wire is 4 meter. The ratio of diameters of two wires of same material is n is to 1. Diameters. The length of each wire is 4 meter. On applying the same load, the increase in length of a thin wire will be n greater than 1. The ratio of diameters are given as n is to 1. N greater than 1 means this will be thin one. Hmm? Increase in length. So what did you get? What did you get? So accordingly, this is given, right? So the direct expression you can use, but here what is given? N is to 1. What is that? Ratio of diameters. Diameters, radius means diameter by 2. So accordingly, I have to take anyway proportionality proportionality relation. If you take n is to 1, you'll get, right. So area is equal to pi r square. So we'll take accordingly. So then have you tried? Yes, sir. Hmm. 1 by n square. Not n square. You cross check. Maybe you have reversed this ratio. Where? Show me that I can check whether the mistake is there or not. Hello. So, again that. Next one. Present and correct. Next one. One second. What is that? What is given here? Let us see once again. 7. The ratio of diameters of two wires is this. Length of each wire is this. So L1 by L2 is 1. And applying same load means F1 by F2 is 1. Increase in length of the thin wire will be means delta L1 in terms of the other one. Delta L1 by L2 is how much? Thin wire means delta L2 by L1. This is L1 into L2, right? Delta L1 by L2, delta L2 by L1. I think that you have taken reverse here. This is first and this is second. Yes, second is thin wire. Yes, you have taken 1 by 2. You have taken 1 by 2. This is thin wire. That means delta L2 by delta L2 is n square times its length is 1. So L square times. Correct. That is correct only. Length of a metal wire is 10 centimeters when the tension it is 20 Newton and 12 centimeters when the tension is 40 Newton. The natural length of the wire is length of metal wire is this. And tension is in this much. This okay. So that means total length. That means L plus delta L is this. So what you can understand here is 10th one. So the length of a metal wire, so if you have, say for example, this is a wire, and this if you apply a load, so that this is a force, right? Length of the metal wire, it is original length, so it increases by a small amount. Delta L1 is L1 delta L1. So I mean the force F1 is 20 Newton. Total length is 10 centimeters, means L1 plus delta L1. L1 plus delta L1 is how much? 10 centimeters when F1 is 20 Newton. Similarly, if there is another wire having its length is L2 plus delta L2 is equal to how much? 12 centimeter when tension in this is F2 is equal to how much? 40 Newton. The natural length of the wire is length of a metal wire is this, when tension is this. Oh, same wire only. So initial length is same. L and L1, L2 are same. L plus delta L1 is this. L plus delta L2 is this. That's delta L1 when this force acts. Delta L2 when this force acts. This force acts. So that means we don't know what you're asking to find. What is the original length or natural length is the question. So what you have to take here is so if you say the force is increased means delta L is changing, delta L1 delta L2, so volume remains same. If length is increasing, volume remains same, area decreases and hence volume remains same, right? But in this case forces are given, they are asked to find natural length. So Young's modulus, same wire, so Young's modulus is same only. Y1 is equal to Y2. So can we take this as can we take Y is equal to stress by strain. Stress is force by area. Areas also everything is same. FL by A into delta L. Right? So you can take this from this as F is same. No, F is not same. L is same. Area is same. Huh? Yeah. Delta L, you can take it as 10 minus L, 12 minus L. Right? So you can take it as Y is also same. So you can take it as Y1 equal to Y2. Y1 is equal to Y2. Y1 is same, loads are different, right? F1 L L by area is same, A into delta L is 10 minus L. 10 minus L is equal to F2 L by A into 12 minus L. 12 minus L. So here L cancel, A cancel. So you can say F1 F2. What is this F1? 20, F2 is 40. So you can say what is it? 20 and 40, 10 and 40. 20 and 40. So it is 20 by 10 minus L is equal to 40 by 12 minus L. So once twos, if you cross multiply, 20 minus 2L is equal to 12 minus L. So this, if it comes here, plus 2L. 2L minus L is L. So if it comes here, L is equal to 20 minus 12 is 8. 8 centimeters or 8 meters. They are given in centimeters. Oh, they have given centimeters length, so this will be in centimeters only, right? In centimeters. 10 to 3, 8 centimeters. 8 centimeters. That's how I can take it. Okay? That's it.